we have an expander which receives 0.5 kilogram of air. So the expander decreases the pressure. So in this expander there is some work output and there is some heat transfer as well, because you have to find out the rates of heat transfer and work done. You have to neglect the kinetic energy. So the inlet state is at 200 kilopascal and 300 Kelvin. The exit state is at 400 kilopascal and 300 Kelvin. So the process is reversible and isothermal. Process reversible isothermal. So we have to find out the work done. So the work done and the heat transfer. So for a reversible process, Sgen equal to 0 and ds equal to del q by t, where t is now isothermal and is fixed. So Q12 equal to T multiplied by S2 minus S1 is equal to T into. So for an ideal gas, let us assume that air is an ideal gas. So for the ideal gas, what is S2 minus S1? We will make use of the property relationships. TdS equal to dH minus VdP. So this is equal to Cp dt minus Vdp. So this will be S2 minus S1 equal to Cp ln so Cp dt is 0. So this is equal to minus Vdp by T integral. So this term is 0. So S2 minus S1 is equal to minus R ln T2 by T1. We are using the ideal gas equation. V by T is equal to R by P. Okay, V by T using the ideal gas relationship, and we substitute this here. We get, after the integration, I've directly written the answer. This is what we get. So S2 minus S1 is equal to R for air. So the R for air is approximately equal to minus, okay, so the R is equal to 8.314 kilojoule per kilomole Kelvin, and 1 kilomole of air contains how much? 28.97 kg per kilomole ln P2 by P1. So P2 by P1 is what? 400 divided by 2000, and 400 divided by 2000. So this is equal to 8.314 divided by 28.97 into 10 raised to 3 multiplied by ln 2000 by 400. I have absorbed the negative sign into the logarithm and written the inverse of this. So this is 5. So let's see what S2 minus S1 is equal to. So the entropy change is 461.9 joules, because we have written the kilojoule as 10 raised to 3. In fact, let us not use 10 raised to 3 and write everything as kilojoule only. So this is kilojoule per kg Kelvin. Okay, so to find out the heat transfer, we have to multiply by the temperature. The temperature is 300 Kelvin multiplied by S12. This is the heat transfer. So this has to be multiplied on the mass flux as well. The mass flux is 0.5 kg and R equal to 0.5. Q12 is equal to S12 multiplied by m dot. Similarly, W12 is equal to what? So the work done by the expander, we can write it as Q equal to Q plus m dot H I minus HE minus W equal to 0. So this W is equal to Q12 plus m dot times H1 minus H2. What will be the expression for H1 minus H2? For air, it has to be 0. Therefore